Hello and good afternoon. This is basically a continuation of our previous tutorial about Lora gateway and Lora nodes. The only difference this time is I'm using the ESP-IDF SDK, which is the official SDK for developing something for the ESP32. I have ported some of the libraries that we're using for this case. I have a library for the OLED display and a library for using the HTU21D. And most importantly, I also ported the lmic library that we're using the previously with Arduino. I ported it to the ESP-IDF SDK. So before you can make use of this system, you better need to download my code from GitHub. So as you can see, I had it on here. I don't know if you can see the URL on my browser. Okay, so there you have it. Under components, you'll find the libraries that we're using. I have a library for HTU21D, SSD1306, and of course the lmic library for Lora. I also have a library for Cayenne LPP, which is a low power packet protocol. We're using this one to upload our data to TTN. Going back into ESP32 lmic, there's a few things that you need to modify if you ever want to adopt this code into your system. Under the main folder, main.cpp, need to modify, of course, your network session key, application session key, the device address, and probably you also need to modify the sleep seconds. This is basically the interval between the sleep time and the wake up time. If you want, you can stretch it out a little longer, say about 1 minute. Your pin mappings for your radio, and also the frequencies that you're going to be using. Now notice that this code is actually using 915 megahertz Lora frequency. If you have a different radio, for example, that used to work for the European version at 868, you need to modify the library in order to adapt to that particular system. I'll show you how you can adapt your libraries to make sure it works for 868. You go to components, under lmic, include. You first need to modify Lora base at H. Make sure that you're choosing the correct frequency here. If you have a 433 megahertz European version, you might need to modify some of the frequencies here. Wait a minute, where is it? Here. This is for the 915 megahertz. And under this section, you probably need to modify the frequencies being defined here. Other than that, you go also into this file called ESP32hall.h. This is where we define what type of radio that we're going to be using, as well as the type of frequency or region that we are. So here I have defined it to be CFG US 915. If you're using the European version, then you need to undefine this and comment this out. Okay, so once you've downloaded this code from GitHub, you need to compile it with ESP-IDF. Do a make menu config. I'm going to do it now because there are actually a few things here that you that are required in order for you to run it on the health tech, this board here that I'm using. Okay, I'm going to do a make menu config. Okay, so here, okay, this is not the correct screen. Let me try to exit. You need to modify the serial port that you're going to be using. In this case, I'm using, of course, this thing is using CP2104 or something. So I'm using this device, a serial port that that we'll be using. Another thing that you need to modify is this one under component config. Go to ESP32 specific. And you need to make sure that the main crystal frequency here is set to auto detect. Main reason why you need to modify that is by default this device actually makes use of I think a 26 megahertz main crystal frequency. and I just set it to auto detect so that when we try to start up you don't need to select. Okay, now that we've set all the requirements, the configuration in make menu config, you can just do a make flash to program it. And after doing a make flash, we're going to do make monitor to display and to reset the device and monitor the serial port, what comes out from the device. So after I do that, I'll just do make monitor this time. I'm not going to flash the chip again. Do a make monitor, and as you can see now, we have something displayed on the screen, which is basically the temperature and humidity coming out from this HTU21D, and sends that data to our gateway. So as you can see, if ever we have something here, our gateway is also updated, and this gateway will forward that data into TTN. Okay, so that's it. I hope you enjoyed my video, and if you ever need to ask me about something more specific, just ring me through you can send an email, or you can send me a mail. Sorry, you can send me an email, or you can drop me a note on my Facebook or something else. Okay, so that's it for now, guys. See you. Bye.